There are two types of hearing loss that you're responsible for knowing. The first is conduction hearing loss, which may be the one that you're more familiar with if you know anyone that wears a hearing aid. With conduction hearing loss, we're talking about damage to the ear's conduction system. So think about the job of the eardrum, but the middle ear in particular, to conduct or to send messages into the inner ear. Damage to the eardrum and the middle ear bones means that those vibrations aren't getting passed on. They're not amplifying those vibrations into the into the inner ear. So what a hearing aid does is it helps to amplify or turn up those vibrations so that they can be processed by the inner ear, specifically the cochlea. Sensory neural hearing loss is different though, and this is a type of hearing loss that is not corrected for by a hearing aid because it's a result of damage to either the cochlea's receptor cells, those tiny hair cells on the basilar membrane, or damage to the auditory nerve. This is also known as nerve deafness. While a hearing aid may not correct for sensory neural hearing loss, a cochlear implant in some cases does. What a cochlear implant is doing is essentially performing the job that the cochlea is unable to perform. So it transduces sounds to electrical signals, just like the cochlea would normally do if it were working properly, and stimulates the auditory nerve through electrodes that are threaded into the cochlea. Here's a little video that explains a little bit more about what a cochlear implant might sound like.
One of our Patreon patrons, Captain Nick, recently wanted to know what the world sounds like through cochlear implants, which turns out to be a pretty popular and interesting question. Because if you don't have the implants yourself, you can't really know. Cochlear implants are one way for someone who's deaf or hard of hearing to hear speech, and to understand what they sound like, you might be tempted to put the business end of one up to a mic and listen. But if you did that, all you'd get is silence, because cochlear implants don't actually produce any noise. Confused? Let me explain. There are two main types of devices that help people hear: hearing aids and cochlear implants. Hearing aids are basically miniaturized amps and speakers, meaning the world sounds a lot like it would to someone whose hearing isn't impaired. Of course, for a hearing aid to work, the person has to have some amount of hearing in the first place. If they don't, a hearing aid won't help. Cochlear implants allow people with profound hearing loss or even complete deafness to hear speech by bypassing most of the ear altogether. What it puts out are electrical currents, not sound waves, which is why it's silent. Cochlear implants consist of a mic, a processor, and a receiver with an electrode array. The electrodes are surgically implanted into the cochlea, in case the name wasn't clear. Your cochlea is a part of your inner ear that converts sound waves into electrical signals, which then travel to your brain through the auditory nerve. It's a hollow tube that's coiled in on itself, which makes it look a bit like a snail shell. And it's lined with special cells called hair cells that trigger nerve signals when they detect sound waves. If these hair cells aren't working because they never have, or because of some kind of damage, then it doesn't matter how loud a speaker you put in your ear. You won't hear sound well, if at all. So a cochlear implant kind of acts like a hair cell replacement. The electrode array is implanted so it can stimulate parts of the cochlea directly. The mic takes in sounds from the world and passes them onto the processor, which then crunches all that sound data and interprets it into about 24 channels, each corresponding to a different frequency of sound. For each channel, there's an electrode in the array that zaps a certain spot in the cochlea. So what you hear is what your brain interprets from the combination of signals. But those sounds aren't the same as what the mic picked up. There are thousands of hair cells in a fully functional cochlea, which is why hearing people can pick up a whole range of frequencies. With only 24 channels or less, the sounds from a cochlear implant are so different that a lot of people who get them essentially have to train their brains to hear. It's impossible to completely replicate what it sounds like without zapping your cochlea, but if you've ever heard one of those talking dolls when it's running low on batteries, it's a little bit like that. The channels the implant uses are specifically designed to amplify speech and make it interpretable, but they're not great at replicating the complexity of real-world sound. As one person with a cochlear implant explained to NPR, the implants especially fail at relaying pitch and timbre. Because of that, it can be especially difficult to understand tonal languages like Chinese, or to isolate individual voices talking in a crowd. Researchers are working on ways to make cochlear implants clearer, but for now, even the best implants we have make the world sound very different. But for those who choose to get them, it's a way to listen to and understand speech, even if it sounds a bit strange. Thanks to Captain Nick for asking this question, and thanks to all of our patrons who keep these answers coming. If you'd like to submit a question to be answered, you can go to
It is so important to protect your ears. I linked in your notebook to a website that you can go to learn more about protecting your ears, but this is essentially showing you healthy versus damaged ear fibers. So think about that basilar membrane of the cochlea that is made up of those tiny little hair cells, or the cilia, that are responsible for transducing. This is what they look like in a healthy ear versus what they look like in an ear where those fibers have been damaged, and they're not able to be repaired once they're damaged. I just want to share with you real quickly, my mom, several years ago, found out that she had a benign tumor growing on her auditory nerve. It's actually called an acoustic neuroma. It's pressing on her auditory nerve, got to the point where it was large enough and was causing enough complications where it needed to be removed. And that resulted for her in sensory neural hearing loss, because when the doctors went in, they went in through an area that damaged not only, I believe, her middle ear bones, but it damaged the auditory nerve as well. To the point where if she wanted to regain her hearing in that ear, she would need to probably have a cochlear implant.